Okay, welcome to week 9. These are our last sections before the test. Hopefully you all have your proctoring appointment scheduled. Remember, you need to be scheduled in an Ivy Tech testing center. Have your non-graphing, non-programmable calculator. Show your work numbered in order down the page, neat. A lot of you, it made a big difference on your score. You know that from the last test, so make sure you show it. Any questions on the test? Okay, 21 questions this time. Project 2 is also due next week. Make sure you follow the instructions. Print everything out. It is 2 spreadsheets. You'll copy the one. Make sure you copy it so that it's still formatted. You'll make the changes to save 2,000 pounds of CO2. Make sure you label the vampire appliances and use the standby watts and non-usage hours. Okay. Your Test 2 review is found in Module 10 under Learning Activities. There are the answers available so you can check yourself while you're preparing. We'll go over as much of it as we can in class on Monday. Then I have the note to come to class on Monday. That's for my other classes, so you can start studying early in the week. We have 3 sections, 16, 17, and 18. So we won't get to go over as much from each section as we normally do. Section 17, you need to make tables for all of it. I have worked them all out, so I will show the tables even though we can't go over all of them, but they'll be recorded. Then you can go back at the video and look at them because it would be very hard if you're all emailing me about your individual questions for me to type all of your tables individually in email. So please use the videos and go back and look. Also, if you miss a problem 3 times, you can watch the videos of the problem because making the tables is key. We'll go over a couple of them, and I have worked out every table that you need so that you can look and see. It's just we won't have time to go over it. Also, section 18 seems to be one people do the worst on. I think they just don't get to it, and it's actually some of the easiest problems. It's just an unfamiliar language. So don't skip 18. It'd actually be some of your easiest points. So do not skip 18 or think, I don't know what these words mean. Actually do it. It'll be some of your easiest problems. Okay. Any questions before we get started? Okay, we start out with 16, which most people like this section. It's on probability. The basic thing you need to know for probability, it's number of desired outcomes, what you want, over or divided by number of total outcomes. Sometimes it's not so easy to determine how many of each you have. And then the first question is just asking you about how we can write these things. They can be written in fraction form, decimal form, or as percents. Okay? All of probability has to add up to 100%. That's what it is as a percent. It would be 1. So 0 to 1, 0 to 100, or as a decimal, which we have here, 0 to 1, or as a fraction, 0 to, well, 1 over 1. Okay? Now, this is a good way for you to check, is my answer reasonable? It can never be negative. Okay? It can't be over 1 because it's up to 100%, which is a 1. So the first one would be a no. 0.9, yes, that would be reasonable. 0, yes. can't be negative 2.8. Probability can't be negative. 1/2, is that between 0 and 1? Yes. And 1, yes. So that's a good way sometimes to check, is your answer reasonable? Okay. You have to make sure you have the number of what you desire over the number of total. If anybody has any certain ones they want, this is probably the easiest section. Let me know which ones you want. The exam is 90 minutes. Again, the final is 2 hours, but one in this exam is 90. Okay, I'm going to skip that one and go to number 3. Okay. Angela has 5 fish. When she feeds them and collects the data on which fish eats first, look at the data. I had to look really close. This fish was 9. That's Goldie. This fish, I don't know what its name was. That was a 5. That was a 2. That was a 3. And that was a 6. Okay, so my total outcomes, I had to add the 9, 5, 2, 3, and 6. Because the total feedings then is 25. And it wants to know what's the probability that Goldie will eat first next time. So remember, it's look at the total first. I always look, the total outcomes was 25. The desired is Goldie. That was this first one. So it's 9 over 25. And they wanted it as a, I don't think it said, so it would probably take either answer. But they divided it out and got 0.36. They left it in decimal form. Okay. Definitely real life here. You use probability for a lot of things. Okay. Next one. They usually don't give too much cards on the test. I don't think card problems are fair because a lot of people don't play cards anymore. Some things you need to know about a standard 52 card deck. You have an ace, and then you have 2 through 9, which are numbered cards. Then you have a jack, queen, and king, which are face cards. You have 4 suits, they call them, which are hearts and diamonds are red, clubs and spades are black for the 4 suits. You have 4 of each of the, there's 4 2s, 4 3s, 4 jacks, queens, kings. So it says, what is the probability that you draw a 4? Well, there's a total possible, or 52 cards. How many 4s are there? There are 4 4s. 4 divided by 52 is 1 over 13. As a decimal, 0.077 when we round. I don't know how they got all the way taken out here to many places. Okay. I think I put mine in as a fraction, 1 over 13. The probability of a spade. Well, there's only 4 suits, so it's going to be 1/4. Okay. Or 0.25. Now here's where it gets tricky. A 4 or a spade. Let's think about that. We still know we're out of a total of 52. How many 4s do we have? We have 4 4s. And how many spades do we have? That's a quarter of the deck, which is 13. But this is where you got to be careful. One of those 4s was a spade, and we can't count it twice. So we have to subtract out one of those, or you could have just put a 12 here. You can't double dip. One of these 4s was a spade, so we can't count it in this group. So I'm just subtracting it out so we don't count it twice. Okay, we can't count it twice. So that gives us 16 over 52. Okay. Does that make sense why we can't leave it at 17? Because you're counting a 4 of spades here and a 4 of spades here when it says both. So you got to take it out. You can't count it twice. Anybody have a question on that? Okay. Okay. Number 5. A lot of times it helps to make a table. You'll be making a lot of tables in these next sections to go through all this text. It says, in a study by the Department of Transportation, there was a total of 90 drivers that were pulled over for speeding. Out of the 90 drivers, there were men and women, and some got tickets and some didn't. So we had men, women, they got tickets, no tickets. And we had a total of 90. So you just got to break it all down to get it. Out of the 90 drivers, 33 were men that got tickets, 14 were men that didn't get tickets. So the total men were 47. 8 were women that got tickets, and 35 were women who didn't get tickets. So the total women were 43. And if I check, these add up to 90, which is a good balance. 33 and 8. Total ticketed would be 41. And this balances. So it checks out and balances. Now I can answer my question. What's the probability that the selected person is a woman or someone who is not ticketed? Woman or not ticketed. So start with your total. We're selecting out of everyone. Start with your denominator. Now how many women do we have total? 43. And it's an or, not an and. How many not ticketed? If we look, we have a 49. But we have a problem. We counted the women. We counted the not ticketed. And I know a couple people did the quiz. This is where they were running into problems. Okay. We counted this intersection twice. We can't count these 35 twice. So you have to subtract out where they intersect. Okay. So in our numerator, we got 35 plus 49, but we counted these women with no tickets twice. They can't be counted twice, so we need to subtract them out. So 43 plus 49 minus 35 is 57 over 90, which is the 0.63. And did it say how to put the answer down? It did not. Okay.
I just entered it as a fraction and it converted it for me and counted it correct.
Okay, so you could have entered it this way too. Okay, because it's not saying. Just look if it does say. Okay, you got to be very careful whether it's asking you just for one thing, or the word or the word and. Had it said a woman and ticketed, our numerator would have just been 35 because it has to meet both criteria. Then it's where they intersect. If it's an or, you do the totals and subtract where they intersect. Okay. The second part said on B, probability that it is a man and not ticketed. So we're still selecting out of everyone. What's our total males?
$47.
Plus, what's our total not ticketed?
$49.
But who did we count twice this time? Here's the men, here's the not ticketed. We have to subtract out that intersection if we're doing an or. We can't count these people twice. So we need to subtract out that intersection, which is 14. We can't count them twice. That's a double dipping. So we get 82 over 90, which divides out to be 0.91. Okay. Repeating, 91.1% if you made it a percent, or you could reduce the fraction. Okay. Are you understanding the or? Or you can sum the totals, subtract the intersection. Okay. And is only the intersection of the criteria. Okay, that takes me to 10, where we have some ands. A survey of 213 people, the following data were obtained relating to gender to color blindness. Got males and females, colorblind and not colorblind, and the total. A person is randomly selected. What is the probability that the person is male and colorblind? So again, we're selecting from everybody. So decide who you're selecting from first. So it's out of all 213. Out of that total 213, how many are both male and colorblind? So here's our male, but we don't want total male. We only want the males that are colorblind. So we can't count these 54. We only want this intersection right here. 73 over 213, 0.3427. And again, this didn't tell us how to enter it, but on the test it does tell you how to enter it. It specifies if they want it as a percent to a rounded to a tenth or hundredth, or as a decimal, or as a fraction in lowest terms. Okay, see the difference with and? You just take the intersection because it has to meet both those criteria. Now B. B is the first time you're looking at what we call conditional probability. Be on the lookout for those. That's why I always say do your denominator first. It's who are you picking from? Something has already happened. What's the probability of selecting a male given that the person is colorblind? So no longer are we selecting from everyone. Something has already happened. We're only choosing from those that are colorblind. Okay? It's like if you're all in a room, it says everybody leave except those of you that are colorblind. So no longer do we have all 213. They've already narrowed it down to just this column right here. You can be narrowed down to a column or a row. It's whatever you're given. And they won't always use the word given. But they're telling us this has already happened. We're only selecting out of that 95 that are colorblind. Oops, that's not colorblind. Sorry, that's not colorblind. Not that one. This one's colorblind. We're selecting out of the 118. Okay. The person is colorblind, so we're selecting out of the 118. Out of this 118, how many of them are male? So what's our numerator? If this is the only ones that are there, what's our numerator? Yep, Crystal's got it, 73. Okay. So if we leave it as a fraction, you just make sure it's in lowest form. If you divide it out, you get okay. And then C. What's the probability of selecting a female given that the person is not colorblind? So this time we are selecting from the not colorblind. So our denominator is 95. What's the probability from this 95 of picking a female? So it's 41 over 95, 0.4316, 43.2%. Okay. All right. Just read those carefully. These should be your easy points on the test compared to those long conversion problems. So don't mess up your and ors. Okay. Questions? Okay. Number 11. We have 307 people. Males, females, Democrat, Republican, Democrat, and Independent. A person is randomly selected. What is the probability that the person is male and Democrat? Is this conditional, or are we selecting from everybody? Did it say given, or we already know somebody's chosen? No. So we are selecting from all 307. Out of that 307, we're looking for male and a Democrat. Okay, so they have to be both things. So we're looking for male and Democrat. They have to be male and Democrat. So it's where they intersect. 60 over 307, 0.1954, 19.5%. Okay. The next one says Republican given that the person is male. Is this real blurry or can you see it? Do I need to make it larger?
It looks good to me.
Okay. This is a conditional, so no longer are we doing all 307. It's only the males, which is 159. So it's just this row. Out of this row, how many are Republican? So what's our numerator? Yep, 74. You divide that out, 0.4654, about, because we rounded, about 46.5%. Okay. A female, given that the person is an independent. There's our conditional again. So we know they're independent, so we're only looking at this column. Our denominator is a 40. And out of this 40, how many are females? Would be 15.375, 37.5%. Okay. Okay. Lavonda, you got it now? I think those were the ones you needed some work on. Okay. On to 12. We're back to an or, which is probably the harder one for most people. The person is female or has a college degree. So that's where we take both sums. Female is 41. College degree is 50. Okay, so it can be either of those things, so we add them together. But we counted this intersection twice in both totals, so you have to subtract it out. Okay, so 41 plus 50 minus the 26. We were selecting out of everyone. It wasn't conditional. 65 divided by 100.65. Okay. The person is male or does not have a college degree. It's not conditional. It's out of 100. So the total males is 59 plus no college degree is 50. They intersect at the 35, so we subtract out 35. 74 over 100.74. Person is female or does not have a college degree. We're selecting out of 100. It's not conditional. 41 plus 50 minus 15, the intersection of the two totals. 76 over 100.76. Are you catching on? Okay. There will be several test questions on basic probability, conditional probability, and or will both be on the test. Okay. All right, because we have so much, I am moving on to 17. 17 was a section that was totally new to me. I'm sure a lot of you had never heard of this. The medical students, people that were already in nursing, in my classes had heard of it. It had never been in any math class I had ever taught until this class came along. It was not in 118, the class prior to this. I found it totally fascinating once I understood it. I didn't know the language at all. So it was very confusing for me at first. And then realizing that this is true, I just couldn't believe it. Okay? So you have to learn to make a table. You really can't do this without a table and be very successful. Somewhere I have my tables here. There they are. Okay. So you need to get in the habit, and if you do these enough and practice, it will get so that you can do them. You need to make 4 columns and 4 rows. Okay? 4 by 4. For each one of these false positives, false negatives, when you see that in section 17 or you see it on the test. Okay? Then you're always going to have a test positive and a test negative in the middle 2 columns. Then they have something and they don't have it. Whatever it is, I just wrote something instead of the specific case. Okay? That's how you're going to set up your table. A test positive, test negative in the middle columns. And in the middle rows, they either have whatever it is or they don't have it. Okay? Then you got to know the accuracy of the test. Just write that up there so you know. And where you're going to start every time is with your total population that they give to you. Okay? All right. And I made this a little too big. You're not going to be able to see it here. Okay. Let's go back to the problem now. And then we'll come back to my chart. We'll get all the information we need. Recent news articles have discussed the connection between a rare genetic mutation and breast cancer in women. One of the companies offering a BRCA genetic test is Quest, and this company claims a 98.5 accuracy rate. That's where I got the 98.5 for my chart. You're going to get it somewhere from the question. In the general population, about 1 in 25 people would actually carry the BRCA gene. Somewhere in the question, they're going to have to tell you how many they actually believe do or don't have whatever it is. Okay. Hint, construct a table as in your course materials, and they have to give you a population. They're giving us a population of 42,500. Okay. And then here's our question. What's the likelihood, which means probability, that someone does not have it but they test positive to nearest 1/10 of a percent? Okay, so right at this point, you go back to what we did in the last section. Okay, at this point, you're back, once you've done your table, you're back to doing what we just did a minute ago in section 16. Okay, so now I have everything I need for the table, and it's just time to go to work. Okay, so you start with your population. 42,500, that's where you start every time. Then you need to fill in this last column with how many they think have it and how many they think don't have it. And somewhere they have to provide you with information on one of these, and then you can subtract to get the other. Now they said 1 in 425 have it. Okay, so that means we have to divide this by 425 to see how many have it. Normally they're going to give you a percent where you'd make it a decimal and multiply, or they're just going to say 500 have it. Okay, so we're going to divide by 425, and that tells us 100 have it. That was given in the text, and it told us 100 have it. And then it's kind of like filling in the blanks. If we know 100 have it, how many don't have it? How do we find that? If this is the total and 100 don't have it, or have it, how many don't have it?
42,400.
Yep. We just subtracted. Okay, and that gave us that amount. Now we're ready to move on to the part that is new to most of us. If they're telling us an accuracy rate for a test, if you actually have it, to be accurate, your test should be what? Positive or negative? If you actually have it and the test is accurate, it should be positive, right? So this is where we make this a decimal, 9.985 times 100, because if we have it and we're 98.5% accurate, we should test positive 0.985 times 100 will give us 98.5. And it won't always come out to the same number because you're not always going to have 98.5 there. And once again, now to fill in this other row, all we have to do is 100 minus 98.5, because this is a total. And we know this part. 100 minus 98.5 means that 1.5 that actually have it would have a false negative. Okay, that's called a false negative because they actually have it. Now, these people don't have it, so to be accurate, their test should be negative. So 0.985 times 42,400 gives us 41,764. Because to be accurate, if you don't have it, you should have a negative test result. Now, how do we fill in this other cell in the row? Well, this is our total. We subtract what we know from the accuracy rate, and we're left with 636. Okay. Now we check, this adds up to 42.5. Now we sum these. We sum this column, add these and make sure it adds up, and we've checked it off, it adds up. Now you're ready to answer the question. What's the probability that someone does not have the gene but they test positive? So this is our conditional probability. So we have to start, they tested positive. So what is our denominator? How many tested positive? How many tested positive? What's our total right here? 734. Out of that 734.5, how many did not have the disease or the gene? 636. And what does that equal? 0.8659. It said a percent rounded to the 10th. Okay. And on the test, they're going to ask you, what is this called? They tested positive, but they didn't have it. This is called a false positive because they tested positive, but they didn't have it. So there's an 86.6% chance that you're going to get a false positive. That is extremely high. Okay? That's a false positive. Okay? This takes practice, but once you get down the table, then it becomes easy. It goes right back to the probability. So don't give up and tune out. Keep trying and set up the tables, and it will get easier. Okay? Because it's a very large point on the test. Okay? Let's try the next one. Okay, number 4. A dog allergy. Okay, a dog allergy test for people is 99% accurate. You're going to need that 99% accuracy rate. I got it right there. I made my 4x4 table. Test positive, test negative. Has it, doesn't have it, my total. Only 1.5% of the population has an allergy to dogs. It's actually much smaller. So 1.5% have it. That's where they're giving it to us. How many actually do or don't have it? Okay. Use a group of 100,000 who've taken this test and the information provided to complete a table. If you tested positive, what is probability this time that you have a dog allergy? Round to nearest 0.1%. Okay, so we start with the total and then we complete this column. 1.5% have it. This would be an error for a lot of people because you make this a decimal. It's not 0.15, it's 0.015 times 100,000. Okay. So 0.015 times 100,000 would give us 1,500 actually have it. Okay, Crystal's got that part. Now, then we find out how many don't have it. We just do our subtraction. 100,000 minus 1,500. We get 98,500. Okay. Now comes the accuracy part. These are people that have it. So for our test to be accurate, if you have it, you should test positive, right? And it's 99%, so make that a decimal, 0.99 times 1,500. Do you understand why we're coming to this cell? Because to be accurate, if you have it, you should test positive. If you don't have it to be accurate, you should test negative. So down here it would be 0.99 times 98,500 under the negative column. Because to be accurate, if you don't have it, you should test negative. Then we put it in our calculator. 0.99 times 1,500 is 1,485. Okay. Then we subtract 1,500 minus 1,485 gives us the other cell in the row, 15. 0.99 times 98,500, 97,515. Subtract the total minus what we just found, and we get, okay, sum the columns to get our total. Total that tests positive, 24,7. Total that tests negative. And then before you go on, add these and make sure they add up to 100,000. And they do. Now the question was, if you test positive, so that's a conditional probability, how many tested positive? You're going to have to be asking yourself these questions on the test. I'm not going to be there to ask them for you. How many total tested positive? 2470. That's your denominator. Out of that 2470, how many had a dog allergy?
1,485.
Yep. Divide it out. We get 60.1%. This is not called, this is a true positive because they actually had it and tested positive. If you tested negative, because we haven't had one of these, but you actually had the disease, that's called a false positive, okay? If you test negative, but you actually had it, that is a false positive, because you're going to be asked both those questions on the test, what's a false negative and what's a false positive. Make sure you understand what both of those are, okay? Okay, number 5. Like I said, I'm just going to put it up here because we've got to get one more section in. But you can go back and look at it slowly. This said the polygraph test is 85% accurate. It detects 85% of the people who lie and 85% that tell the truth. A company has 4,000 employees who submit to the polygraph test. It turns out 40 will lie, so there's my lie. And then I subtracted to get the 3960 that will tell the truth. Okay, complete the table. So if we lie, you should test positive. 0.85 times 40 gives me the 34. I subtract 40 minus 34 to get the 6. If I don't lie, an accurate test would say a negative result. 0.85 times the 3960 gave me 3366. So then I do 3960 minus the 3366, and I get 594. I sum the columns, make sure they add up to 4,000. If someone does not pass their polygraph test, that means it tested positive, so the denominator is a 628. What is the probability they lied? 34 lied. 5.4% chance they lied. And again, that is a true positive. Okay. And again, you can go back and look at that later. 6. The Center for Disease Control says estimates the people age 13 and older living with HIV is 1.3 million. And there are 320 million in the US. So our total is 320. I just wrote the word millions. Okay, so 1.3 are the ones that have the disease. So I subtracted to get 318.7 million do not have the disease. The test is 99% accurate, so 0.99 times 1.3 million gave me 1.287 million. Right here, subtracted 1.3 minus that to get 0.013 million. If I don't have it, I should test negative 0.99 times 318.7 to get 315.513. Subtracted 318.7 minus 3.187 to get this number, and then I got the totals. If someone tests positive, what is the probability they don't have it? So I'm looking at this column, and those that don't have it, 71.2, and this is a false positive. They tested positive and did not have it. So please go back and look at that high point test questions. Okay? Because we had to get to a little bit of 18 here. Okay, section 18. Things you're probably not familiar with. The first question is just asking you, what's the inverse of square rooting? And all you do is it's taking the square. Okay? Make sure you can find your square root button on your calculator. You will need it for your test. It's usually the second button on an x squared. Like mine is right here. Here's my x squared. I go second square root, and it's right there. Okay. So this one is doing the opposite. We had to square 5184. It was just 5184 squared. You can either type it twice or just go x squared. And that was your answer on that one. Okay. What this section is talking about is polling and margins of error. Okay, there are different margins of error depending on confidence levels. Polls are not, and you can listen to the elections all the time, and they'll say this all the time in the news, that it's a statistical tie, even though one may have 47 and one may have 52% in the poll, and they'll say it's a statistical tie. And you might be thinking, why? One is ahead. Because you don't poll everybody. You poll a sample of people. Like they may only poll 1,500 people. They're not polling everyone that's going to vote. Okay? So depending on how many people they poll, that says how confident you can be in the results. And that's where confidence levels come. And there's different formulas depending on how confident you can be. 95% confident has one formula, 99 another, This book only deals with the formula for a 95% confidence level. That's it. So the margin of error, the formula you will use, which is only for the 95% confidence level, is 1 over the square root of n, where n equals the sample size. Okay. That gives you the decimal form. Okay. To write it in a percent form, you're going to have to multiply by 100 or move the decimal 2 places. Okay. What this means is if your result of your poll were to come out to be, and number 2 in your homework, it wouldn't print, said the results of some poll were 47%. The margin of error for the poll they gave you, you didn't have to calculate it, was 2.5%. What's the 95% confidence level? Well, they gave you the 2.5. The confidence level, the interval, all you do is take the results of their poll, the statistic 47, you subtract 2.5 and you add 2.5%. And that's the interval. You can be 95% confident that between 44.5 and 49.5% of respondents believe that way. You can't be 47% that that's for sure. You can be 95% confident that that's the results because you didn't poll everyone. Okay? And what I'm telling you is do these questions because it's a very long series of questions and they are very easy. It's just you're not familiar with the language. So let's go through one while we have a chance. This is number 3. An online poll of 3,290 high school students found 75% think cell phones should be allowed in class. What is the population? Okay, you'll have a similar test question. So the population is who did you ask? And you need to be specific. So who did they poll?
3290.
Save that for the next question. Who did they poll? Not how many. Who did they poll?
High school students.
Yep, high school students. And you be as specific as they do. If it said American high school students, you'd say American high school students. Now, whoever said 3290, what's our sample size?
3290.
3290. Yep. Because you're going to get this series, and you can know from the last test how these points add up. 2 points, 2 points, or 1 point, 1 point, 3 points, 4 points. It's going to be a series of questions like this, and they're really some of the easiest calculations you're going to have, but so many people skip this last section because they just don't get to it. They get them all wrong, and they're really some of the easiest questions you're going to have. So the margin of error as 0.1%. If they just asked you the margin of error, you just do 1 over the square root of n, but they're asking it as a percent. Okay, so 1 over the square root of 3290. So make sure you know how you do that in your calculator. Make it a fraction. 1 over second. Make sure you get your square root button. Practice it in your calculator. Enter. So this is it before you make it a fraction or a percent. This is a decimal. So it is 1.7% as 0.1%. Okay. It's not a hard calculation. You just put it in your calculator. 1 over the square root of 3290. That gives you the decimal form. Multiply by 100 or move the decimal 2 places right. Now the confidence level. Okay, make sure you don't do the 95. Make sure you go back and get the statistic. What was the result of their poll? It was 75%. So it's 75 minus 1.7, which is 73.3%, to 75 plus 1.7, okay, 76.7. And then on the test, you're going to have to write a sentence, even though you don't on this question. We can be 95% confident, because that's the only confident level we're doing. Then put your interval. That's 73.3% to 76.7% believe whatever they're talking about. And that is a whole lot of points right there. Okay, and they're not that hard. You're just unfamiliar with them. Okay, we got time to try one more. So please don't skip those. They're not that hard. Okay, let's try 5. Go down to 5. A poll consists of 1,746 Americans, age 18 and over, conducted a survey of May of 2013, found that 55% strongly agree that K-12 students should teach critical thinking. Schools should teach critical thinking. What is the population? I actually filled them in because I thought we would run out of time. Americans age 18 and over. I got that right here. The sample size, 1746. The margin of error as a percent to the nearest tenth. So it's 1 over the square root of 1746, multiply by 100. That came after that. That's the decimal form. Then I multiplied by 100. 2.4%. Okay. And then make the interval. So we go back, get your statistic. It's not 95. That's the confidence interval. The results of the poll were 55%. 55 minus your margin of error is 52.6. 55 plus your margin of error, that's a 2.4. Hopefully I added it right. Yep, 57.4. Okay, so now we know our interval. Now we can write our sentence. We can state or be 95% confident that, now put in your interval, 52.6% to 57.4% of Americans, who were they, age 18 and over, agree with the statement. Okay. I will show number 4 just so you can get the answers to do yourself a check, because we are going to be out of time here. Okay. Number 4 was just similar here. A poll of 1,164 college students found 86% said colleges should do away with final exams. So the population was college students. The sample size, 1164. Again, this margin of error is not tough. 1 over the square root of 1164. Are you all trying it in your calculator? I hope, to make sure you can get the right answer. This is decimal form. Make it a percent. 2.9%. Make sure you find your statistic. Don't use 95 unless that's the result of your statistic. Okay, so then you do 86 minus 2.9 to get the lower limit, 86 plus 2.9 to get the upper limit. And this one didn't have you write a sentence, but how would you write the sentence? Because you're going to have to on the test. What should you start out with the sentence? What do you need to memorize? If it's a 95% confidence level, we can be 95% confident that 83.1% to 88.9% of, who was our population, college students, believe, what was it about? Colleges should do away with final exams. Okay. Please go over this. There's no reason to miss these points. Okay. Questions for me. Are you all registered for your test, I hope, this time? And going to take your test? All right. Have a fantastic rest of the week. Hopefully you're after the review, right, Crystal? Not before the review? Hopefully everybody's after we review on Monday. Ah! Before the review? Can you go after the review? Oh no. Is the 26th next week, I hope? During the week? Yes, the 26th is Thursday. Okay, that's good. Okay, your quiz is good. That's what I wrote you questions or responses in your quiz. Hopefully you got it now. And Crystal, make sure you go over the review. There are answers. Okay, if you need to get to the Learning Center or to the PASI, since you're not going to have the review, remember you got the answers, any that you're concerned with, and discussion boards, remember, are good sample questions as well. Make sure you seek support before you take your test. All right. Have a wonderful rest of the afternoon.